Hello and welcome back to my channel. In this video we're going to be talking about how to use LP to model, that's linear programming, right? To model fractional knapsack. In the last video we talked about how to use linear programming to model 01 knapsack. Please, if you have not subscribed to this channel, please subscribe. It's totally free. So for your fractional knapsack, the thing with fractional knapsack is that our x can be a fraction and our profit also can be a fraction. So for example, we supposing we have w equals 50 and we have c, which is our constraint, equals 10. This means that we can actually pick 1 over 5, right? That's 10 over 50, which is 1 over 5. So for fractional knapsack, you can pick the values, you can pick a part of the item. That's just the thing to know about fractional knapsack. And this also means that our profit can be a fraction. And we can solve fractional knapsack using either greedy algorithm or using an LP solver. The reason we can use an LP solver, if you remember in the last lesson, I said when x is a real number, then the problem is an LP problem. So, and a real number contains even fractions, right? So we can solve using an LP solver. We can also solve using a greedy algorithm. So, and as usual, for modeling this problem, objective function would be to maximize, right? We want to maximize our value. So we want to maximize whatever the sum of this is. We want to maximize VI, XI. We want to maximize this from I equals to 1 to n. We want to maximize this. And we want to, for our constraints, just as we have seen, the constraint is always going to be C. And we have, this is a constraint, WI, XI. So the sum of this always has to be less than or equals C. Also, another constraint is that XI is less than or equals 1 and greater than or equals 0. So we have two constraints there. So this can be solved in polynomial time. That's another thing to note. It can be solved in polynomial time. It can be solved with an online LP solver, and or even graphically, depending on how complex the question is. And you can also solve it using greedy algorithm. So this video is as short as it gets, and that's because we already talked about 01 knapsack in the previous video. So if you did understand the previous video, everything that happening here is almost the same, except that our x can be a fraction and our profit can be a fraction in the real sense of what a fractional knapsack is. So we are going to end this video here, and in the next one we'll look at how to use LP, linear programming, to model bipartite matching problems. See you in the next one.